So now we start chapter 11, which is angular momentum. And the first thing we will look in this is just a review of the torque that we had done earlier, and also do a little bit more on the nature of torque. So just to review, we had a wrench, and its length is some L, and if you apply a force over here at a distance, here's the nut, and the distance is R, then the torque was given as Fy times R, where this would be Fx, which would not create any torque, and this would be Fy, which would create the torque and try to cause this whole thing to turn counterclockwise. So the torque is Fy times R, and if this is the angle theta, then this is going to be Fr sine theta. Now the units would be the units of force, which is newtons, and the units of R, which is meters, and sine theta being dimensionless, so the units are Newton meter. Now torque is a vector, and so it has a direction, and we know that all things counterclockwise have a positive direction. So it's going to be in this case, if the force is like that and it's going to turn counterclockwise, the torque is going to be perpendicular to the page and coming out of the page. So torque is more properly defined as, well, Rf sine theta we know is R cross F, so we can write it as R cross F, and it's not F cross R, it's R cross F, which is the magnitude of R times the magnitude of F times sine of the angle between them. And the sine of the angle is taken as not this one but this one. So if this was R and this was F, we would draw them like this, R and F starting at the same point, and that would be theta. Or here you could just extend that out and say that's theta. So this is torque vector, which is R cross F, which is this, and it will have a certain direction. Okay, and the direction is perpendicular to both R and F. Now, just a review of cross product. This is a cross product, it's not a multiplication, and we will now take the cross product of two vectors. So if vector R is xi plus yj, xi plus yj plus zk, and a vector F is fxi plus fyj plus fzk, then R cross F can be written as a determinant with I, j, k, and we write the first vector, which is x, y, z. The order of the vectors is important, and the second one is fx, fy, and fz. Now the solution of the determinant is, first we take this row and column, so we have the first term, which is I, and then we remove this row and column, so we are left with this determinant, and it's going to be y times fz minus z times fy. And then the next term is, we'll take this row and this column, so it's going to be j, and it's a negative. The first term is positive, the second is negative, and so on. And then we'll have x times fz minus z times fy, z times fx, sorry. And then the third term would be this little vector, this little determinant, going to be k, and well, these are all unit vectors, and it's going to be x times fy minus y times fx. And well, this can be simply put in the numbers and simplify this. So let's do an example, and we'll, instead of having such a long term, we'll just use a shorter, like just 2D vectors. So r is taken as 2i plus 3j, and f is taken as 4i plus 5j newtons. That's meters. Okay, that would have been here. Now, to take r cross f, we'll follow this procedure. We'll write the I, j, and k, and first the r, which is 2i, 3j, 0k, and this is 4i, 5j, 0k. So the first term is like this one, going to be I, it's going to be 3 times 0 and 5 times 0. 3 times 0 minus 5 times 0, so it's just 0 is minus 0, so it's going to be 0. The second term is going to be 2 times 0 minus 0 times 4, or 4 times 0, which is again going to be 0. And the third term is going to be 2 times 5 minus 3 times 4. So these two are 0, so it's going to be simply k, and 2 5s are 10, minus 12, minus 2k Newton meter. So that will be r cross f, a magnitude of 2 Newton meters and a direction plus minus k. We can also do this in a different way. We can write r cross f as 2i plus 3j cross 4i plus 5j, and then we do the normal algebraic multiplications. So 2 times 4 is 8, and I times I is really an I cross I. We don't have I multiplied with I, it's I cross I. And the next is 2 times 5 is 10 I cross j, and then 3 times 4 is 12 j cross I, and 3 times 5 is 15 j cross j. Now, what is I cross I? So we do this on the side. We'll see that I cross I is what we have here. It's the magnitude of the first, magnitude of the second, and the sine of the angle between them. So it's going to be 1 times 1, the magnitudes of these two, and sine of the angle between them. So if this is I and this is I, so the angle is 0, and sine 0 is 0. So I cross I is 0, and similarly j cross j and k cross k are all 0. Okay, so I cross I 0 and j cross j 0. Now what about I cross j? So I cross j is going to be 1 times 1, and the angle between I and j is 90 degrees. So that's going to be 1. But then what is the direction of I cross j? And to get the direction, we draw ij and the k, which is coming out of the page, and we write them so that they appear to be in a counterclockwise order. So I cross j would give us a k, so that's going to be 1k. And j cross I, so let me write them here. I cross j is going to be a k, j cross k is going to be I, and k cross I is going to be j. And in the reverse order, j cross I is going to be minus k, and k cross j is minus, k cross j is minus I, and the third one, I cross k is I cross k is minus j, because we're going clockwise. So with this I cross j, I cross j is k, so it's going to be 10k, that's the first term, and j cross I clockwise, so it's minus k, so we get minus 2k Newton meter, which is what we had before. Now a few properties of cross products. Well, A cross B is not the same as B cross A. In fact, A cross B is equal to the negative of B cross A, which we can see from here. I cross J is K, and J cross I is negative K. And we also have the distributive law, A cross B plus C would be A cross B plus A cross C. Now, one last thing about the cross product is what does the cross product represent? So if this is our x-axis or the I, and that's the y-axis, and the z is coming out of the page, and if we have one vector, let's just keep it along the x-axis, let's say that's the vector p, and we have another vector that's like this, let's have the vector q, then p cross q is pq sine theta in some direction. So q sine theta, this is the angle between them, q sine theta is going to be this line, and if you multiply q sine theta, okay, that's this line, if you multiply this length p with this height, we get the area of this rectangle. So pq sine theta is the area of this rectangle. Now as q gets smaller and smaller, the height of the rectangle gets smaller. Ultimately, when p and q are parallel, the area becomes 0. But if we look at this triangle, and if we make this side the same length as p, and we complete this parallelogram, then the area of this rectangle is the same as the area of this parallelogram, because this triangle is the same as this triangle. And so p cross q is the area of this parallelogram. Okay, so this is equal to the area of parallelogram. But there's a direction to it. So what's the direction of this area? Well, the direction of p cross q is k, because it's in the ij direction. So the result has to be k. So area is a vector. And we will use these results many times in physics too. That area is a vector that's pointing in this direction, but if you look at the area on the back side, on the other side of the paper, on the lower side, that would be q cross p, and that would be minus k. So the area is always pointing in the, what you could say, the outward direction.